have a small announcement. If you don't recognize some text, don't worry. The slides will be shared in the end of the presentation, so you can see all links, code samples, and diagrams. So let me introduce myself. My name is Sergei Chernov. I work at Mira as a platform engineer, and today I'd like to talk about Spring-based integration testing, troubles that we are facing at Mira and ways how we solve this. I'd like to share some insights about this. So at Mira, we make online whiteboards for collaboration. Anybody using Mira here? Nice. So we use it daily. We haven't decided which way to go, so we have both huge monolith and around 200 microservices. But the problems that we have there are a bit different, but both are scale. One is a huge monolith application, and when you have lots of microservices that run on the same CI/CD environment, it's also a trouble which you need to optimize and solve. So also we have hundreds of builds in our CI/CD per day, so our scale is quite big. The monolith application is also more than 1,000 modules. Our Spring stack, our technical stack is quite classic. So we use Spring Boot 3, we use TestNG and Unit 5 for testing, and we use test containers a lot. So what I mean that we are not using mocks or databases like H2. Instead, we prefer real databases as a containers for relational databases, cloud components, message queues, and other systems. So with the project growth, at some moment we start observing lots of troubles. So our tests were taking much memory, it were taking much time, and they were some kind of flaky. Also, our tests were conflicting each other. For example, trying to open the server ports on the fixed number of ports. And it became a more or less popular excuse not to write integration tests at all, because they're flaky, they're slow, inefficient, etc. We're trying to find some solution for this, but in the worst case, it could mean that we need vertical scaling, which is quite expensive, and also it doesn't solve problems on the long term. So we had to find some scalable solution there. Also, our CI/CD cluster was almost dead because we were trying to spin too many Docker containers. And it was a big problem for our CI guys that worried about this. So our teams work independently, and one of the limitations was that it's not possible to review literally every pull request. So we had to define some scalable and reproducible ways to solve those problems. And also we tried to find some solution that will work both for the monolith and our microservices. Initial discovery showed that the root cause of the problem is that eventually in the runtime there are several Spring contacts working simultaneously. So for this reason we had many active beans, which sometimes were heavyweight, for example, Docker containers. We had lots of thread pools which were active, and as a result, our Docker environments were overloaded, our logs were overloaded with random exceptions, etc. So before we go ahead, I'd like to emphasize, so when we're talking about integration testing, what I actually mean, because the definition may differ depending on the company you work at. I mean those tests that are executed in the same JVM as the code that you validate. So for example, in the classic Unit 5, those tests are annotated with add Spring Boot tests or using extends with Spring extension. In case if you're using TestNG, you're extending the specialized parent class. So again, those tests are bootstrapping Spring contacts themselves. So let's take a closer look to just some sample JUnit Jupyter test. What happens behind the scenes when this test is executed? In the very beginning, Spring analyzes some kind of meta information which is defined on the test class. What it means? It's usually checking some annotations like context configuration, active profiles, test property sources, and a few others. And this all meta parameters are aggregated to a single object which is called merged context configuration. It's a bit boring list of all those parameters, but I'm mentioning there in case if you want to see the exact definition of this. Why I focus attention on this class? Because this is the main criteria if two different integration test classes have same configuration or not. So what happens then? This merged context configuration is a key for the cache of Spring context. And if there is existing Spring context which matches this configuration, it's reused. Otherwise, it creates new one and puts in the cache. So the logic is pretty simple here. And this is the root cause of all troubles that happen on a big scale. At some moment, this cached number of the bigger number of cached contexts can be quite huge. Let's consider a sample suite of 8 tests. So you can see there is some color distinction between them. And for example, test 1, test 2, and test 7 has the same color, which means that they have the same configuration. And what it means, they use the same context. What happens when we run those tests, the suite, in our JVM, one by one? Test 1 creates context the first time. Test 2 reuses the same context because its configuration is the same. Test 3 will create the new context because its configuration is different. Same will happen on test 4. So eventually, if we have 4 different configurations, we will have 4 different contexts, which will be closed at the very end of the JVM lifecycle. And it can be too late. What I mean, at this moment, more close to the end of the lifetime of our test JVM, we can already observe different type of problems. So first, tests conflicting each other, sharing the same resources like fixed ports. More context can also mean that we have more active bins like test containers, more Docker containers. And so what this also means, each time when the new context is created, it not only consumes more resource like CPU and memory, but also it takes time. So for example, in our monolith applications, some of the integration tests need around 2 minutes just to create the context that is then used in a test, and those tests take just a few seconds. The relation between this time to initialize the context and run the test can be different, like 50-50. But note that each time the separate context is needed, it also takes more time to execute your test suite. So you can easily recognize Spring banner in your test. So how many times you see the banner in text log usually means how many times the fresh, separate Spring context is created. So for now, we already can have some intermediate goals when we understand the root cause of the problem here. So we need to limit the number of active contexts if it's possible. we need to reduce the number of unique configurations to reduce the number of active contacts. Also, in some situations, we still need to create more independent configurations to test more precisely or some special scenarios. So ideally, we need to reduce the overhead of creating each new separate context. And the last one is, can we revisit and adjust the standard logic of test execution? So let's go through optimization advices. So if you ever inspected problem that I'm talking about, I believe you're aware about well-known annotation which is called add dirty contacts and what it does. So after a test, or maybe before the test, it closes the contacts, and in many cases it indeed solves the problem. Initially, this annotation was created for scenarios when the shared state of the context was changed by a test in a way that it should not be reused by other tests because it can break subsequent tests. In the worst scenario, such dirty context can be set on the parent integration test class, and as a result, each test will close the context after it. And it can work quite well, but the time of the test to be you need more time to execute the test suite. Possibly a better solution can be reducing the size of the context cache. So by default, context cache has a size of 32. You can reduce it to a smaller number like 4 or maybe even 1. To do this, you need to define a property. It's called Spring Test Context Cache Max Size in a file called Spring Properties, or you can pass it in Maven failsafe plugin configuration. So what will happen? Let's consider the case when the cache size is only 1. For subsequent tests that have the same configuration, like test 1 and test 2, we will now already reuse the same context, as you see, right? But then when we'll start the new test 3, it will create the new context and then shut down the context, the first one. So the cache will also always be not more than 1. So it's already better than original dirty context on all classes, but it will only benefit in time for those scenarios when the same configuration goes sequentially. Also, what's the problem here is those small overlays, because older Spring Boot implementations had such policy that they create new context before the previous context is closed. But this will be fixed in the upcoming Spring Boot 4. Okay, another optimization advice. So to reduce the chance your integration tests declare different configurations, I mean configurations that are considered as non-equal by Spring Test Framework, the very classic approach is to move all those configuration annotations to a parent base class. And in subclasses, try to avoid such declarations at all. It will increase the reusing of the same context a lot. Also, there is a very nice annotation which is called mockbean. In the latest version of Spring Boot, it's called Makita bean, similar like spy bean. You should be careful with using such annotation. Just keep in mind that it is one of so-called customizers. What I mean, if you declare annotation like this, it will increase the chance that this particular class will create separate context. So if you really need this, try to move it to reusable classes, to parent classes or shared integration test classes. I mean, share it between different classes configuration. Another trick is to reuse static singleton Docker container. So instead of creating Docker containers, I mean managed by test containers, as a regular Spring Beans, you can use static singletons. It will reduce the number of possible created beans working simultaneously, and also reduce the cost of creation of each next context. It's easy to implement this. This is just an example of Spring configuration that does it. I'd like to just focus attention on two things. So first is you need to override the destroy method because by default, when the Spring context is closing, it will also shut down all beans, including test containers managed Docker containers. We don't want this, and intentionally override it to no op. Those containers will be shut down by utility which is called rook when the JVM will be shut down. And then instead of simple creation of a container like DynamoDB or maybe Postgres, you use pattern which is quite similar to static singleton. This can save a lot of resource. Also, if you use techniques like flyway migrations on a big scale, it could make sense instead of applying all those migrations on each test scenario. That can take a lot of time. So for example, in our code base, we have around 600 of flyway migrations, and it takes about 20 seconds, which increase the build time a lot. You can pre-create Docker images with all migrations applied. Mira open sourced their solution, which is called persistence tooling. So you can find examples here and the documentation how you can create this in your code base. So this can inspire your test engineers and also be good optimization that we use in our projects. One more optimization related to the databases is a lazy initialization of data source. If you have single database, which is quite usual for microservices, maybe you will not benefit too much from it. But if you have a monolith application that has lots of data sources, lazy initialization of those containers can help you a lot for the sake of optimization. What it means? Usually you define Docker container and the data source beyond those Docker container, which are initialized eagerly. Instead, you can use some kind of lazy initialization. Again, don't worry if you cannot recognize all the code, but idea is very simple. You wrap standard data source to some lazy initialized delegate. And on the very first call of data source get connection, it will spin the new container once. The trick is, if you, for example, declare 10 containers with their data sources, but most test scenarios will need only 2 or 3 of them, they will be just never created. And this can boost the time of executing tests a lot and reduce the average number of created containers. Okay, one more optimization is related to ports. It's pretty convenient to use fixed ports because it simulates more production-like behavior. But the idea is to prefer random ports. If we are talking about Spring Boot tests, we have special parameters for this. It's called web environment. And in the integration test, you can obtain the real port that you can use. So what it will allow you to do, you can create more context on parallel, or you can build more modules in parallel, or you can build more projects in parallel if they rely on dynamic ports, because they will never conflict, and it will allow to scale better. Same advice is for using test container management Docker containers. Do not rely on fixed ports. All best practices for test containers recommend to use dynamic ports instead. one more thing related to the life cycle of your Spring beans. So the sample above looks quite innocent, but there is a problem. So what happens here? The new Postgres container is created and started, and we create data source beyond this and expose it as a bin. When we start such container and test, everything will work quite well. The problem happens when the context is shut down. So only the data source is exposed as a bin, so Spring will manage the life cycle only of the data source. It will close data source, but the container will still stay alive. So instead, what you can do is to define separate Postgres container as a bin and inject it as a dependency for your data source. So according to their dependency, Spring will close them in proper order, backwards. Note that test containers rig daemon will eventually close them all. But if you shut down your containers properly and eagerly, in average, on a huge codebase, you will see a good benefit of this because resource consumption will be reduced. One more similar case is related to executor services. So the code above is more or less classic. What it does, when the service is created, it creates a scheduler and there is some scheduled task. But what should be done there is proper shutdown procedure, which will also stop the thread pool. This way we avoid dangling thread pools, which stay alive after the Spring context is evicted. Okay, those are more or less standard advices that you can find a lot on the internet. In our case, it was not enough because of the scale of our application, so we decided to dig a bit deeper and to find maybe we can customize the standard behavior. So let's take a look again on our test suite. We have 8 tests that have 4 different configurations. What we can do, if in the beginning we know in which order our test will be executed, we can know after each particular test if this is a last class that will need this context or not. So for example, test 3 is known that after it there is no other integration test that will need its context. So we can eagerly close the context after test 3. Same for test 4. But not for test 2, because we know that test 7 that is executed later will need this context. So if we somehow implement this more smart context closing, you can see that the average number of active Spring contexts is already better than original one. This idea is complementary with the second optimization. What if we reorder the original list of integration tests to group all tests that use the same configuration and hence use the same context sequentially, and then eagerly close the context? In this case, we will have not more than one context at the moment, always. I'm talking about single thread execution mode for sure, but still. So how to implement this? So we need to reorder tests and we need to implement smart auto-close context listener. The problem here is that the Spring test as a framework cannot control the test execution order because JUnit platform as a test engine delegates to Spring, like Spring extension or Spring runner, test execution like initialize context, close context, etc. So we need to control order of tests on the level of test engine. But test engine itself is not a verb about Spring, and that's the opposite. So I don't want to dig deep into details because all those you can find our open source project. I just want to explain a few key things. GUnit gives you a simple interface which is called class orderer with input the list of files that are executed and returning ordered list in which they should be executed. So how will it work? It will go through all those tests, calculate their configurations, and according to their configurations, order them. Calculating the configuration is a very cheap operation. This is crucial here. So you don't need to create heavyweight contexts, bootstrap, Docker containers, etc. So this takes just a few seconds, even for huge test suites. And the second part, how we can eagerly close context of the test. So we need to implement our custom test execution listener, which has trivial logic. If current test class is last for this configuration, close the context. Because the test class ordering is known and predictable in the very beginning. So that's briefly it. Yes, and no more slides with code. So I'll share some numbers. This is the chart with a timeline from left to right. The number of active Docker containers that were active on Docker environment when you try to run test suite of the largest module of Mira. So what actually happened? After around 25 minutes, it bootstrapped almost 120 containers and then started failing with out of memory because Docker desktop just could not spin that number of active containers. So, and then other charts show the number of Docker containers with different combination of those optimization. So red one is when only eagerly close our contacts when we know that it's not more needed. Yellow is combination of smart ordering and smart closing and reordering. And the green one is adding one more optimization with lazy initialization of data sources. So what you can do, you can see here, it's not only consuming less resources, so less Docker containers in average means less memory, but it also executes faster. And there is a simple explanation for this. If your Docker host doesn't need to manage all those mostly dangling Docker containers that consume resource, that need to some context switching, etc., your overall system performance is way better. So this is a significant result that we achieved in our project. Also, we had to do this because otherwise we would be just blocked with any other new tests. One more interesting outcome, which was a bit unexpected here. Now you can connect your performance tool and track what's going on during, profiler, what happens during test execution. And we have some kind of serial Spring context switching one by one. And now we can easily recognize, yes, all those drops down is closing Spring context. But you see there is upcoming trend, which means there is a thread leakage, which is better to fix because this can be a sign of production bug, but at least you can optimize your integration test environments. And very similar if you track the heap usage. This also looks like a heap leakage. If you do not eagerly close Spring context, you just cannot recognize Is it heap leakage or thread leakage, or is just increasing resource consumption because you execute more and more tests? So one more interesting outcome is that when you address issues like this in integration tests, it can help you to possibly find production issues which are maybe not visible or visible when the application is working for a few days but is still there. It was in our case. Or, and also do proper graceful shutdown, because you need to graceful shutdown Spring context, but you will have less issues when your application is restarting, for example, to update to the new version. So, we didn't want to bother our engineers to some very complicated solution, and for this we built a library that you can just add as a dependency, as a Maven dependency. It also works as a Gradle dependency, which supports Spring Boot 2, 3, and even Spring Boot 4. And the instruction is pretty simple. Add a dependency, remove dirty context from your test classes to rely on smart dirty context logic of the library. Optionally, you can extend logging to have more information. And one of the first benefits that you can have, run the test suite and it will print you the list of integration tests to be executed, and you can easily recognize which tests are using the same configuration and will use the same context, and in which order they will create and shut down the Spring context. This can be quite interesting, so you can conclude how efficient it works and why it happens. So another question, like, does it make sense for small projects? Results for smaller projects can depend. So ideally, there is no difference if you add the library and you have the same build time and more or less similar resource. But again, if you have a big scale, like dozens or maybe hundreds of microservices, it makes sense, because the average resource consumption on your shared CI/CD environments will be way smaller. But sometimes the build time is way better. So some projects reduce like twice running the tests, or 30%. So as an idea and proof of concept implementation, it was submitted to the Spring project, and I also got some response from the leader of Spring Test. But again, the problem is that Spring on its level cannot access to the order of the test, because that's responsibility of JUnit platform. But the good thing that this guy is leading two projects, both Spring Test and JUnit 5, together with Mark Phillip. So maybe this idea has a chance to be implemented somehow. Unfortunately, latest Spring Boot 4 doesn't have fully implemented this with reordering and eager closing, but they are moving toward this. Also, just worth to mention that we're talking about optimizing the worst case when we have to run all the tests. But if you have a huge code base, there are three crucial factors that you need to consider. It's local and remote build caches, it's test distribution, and predictive test selection that can significantly reduce load on your test infrastructure. It's absolutely separate topic, but it's also just worth to mention there. So, and as a summary, try to reuse context, understand how it's working, the reusing of existing context. Try to initialize late and release eagerly. And if you're working on the bigger scale, be ready to revisit standard behavior. It's okay when you have projects like of thousands of modules. Also, my personal recommendation is invest to your integration testing, because in the long term, this is one of the best way to have a better quality of your application. It makes much sense, and it brings you a lot of value. And also, don't think about integration test optimizations early. Write integration tests together with your features, because later it will be way easier to optimize your integration tests than to write new integration tests for existing codebase. So the project that I explained is available as open source. It's licensed as an Apache license, so you can use it as a dependency because it's distributed on Maven Central. Presentation slides are also available. And that's it. Thank you very much.